Assalamualaikum and hi everyone. My name is NURUL. Today I will explain two important medical conditions, that is bloodstream infection (BSI) and sepsis. This blood is normally a sterile environment. However, bloodstream infection occurs due to microorganisms such as bacteria, fungi or viruses entering and multiplying within the blood. Microorganisms in the blood are usually rapidly cleared by the immune system and filtering organs. But in some cases, they can cause an acute infection and trigger sepsis. Septic response to infections that lead to circulatory collapse, multi-organ dysfunction, and death. This infection is common in hospital, life-threatening, and increasing in prevalence. Sepsis is defined as a life-threatening organ dysfunction caused by a dysregulated host response to infection. Sepsis means that in sepsis, the body responds to infection which causes damage to its own tissue and organs that eventually lead to failure of the organs and death. Initially, the infection triggered an immune response that released pro-inflammatory cytokines and recruitment of immune cells like neutrophils and macrophages. The aim of this inflammatory response is to control and eradicate the pathogen. However, in patients with sepsis, host response becomes dysregulated and can cause systemic inflammation, further leading to organ dysfunction. Sepsis results from increase in metabolic demand combined with insufficient circulation.
So today we will look into one of the most widely used automated system, which is the BD-BACTEC blood culture system. Now we jump into the principle. The BD-BACTEC system operates on a simple but powerful principle. It detects microbial growth by measuring carbon dioxide production. As microorganisms grow in the culture bottle, they release carbon dioxide. The system uses fluorescent sensor whose signal intensity increases as carbon dioxide is produced. The machine reads this fluorescent and interprets it as evidence of microbial growth. Next, the key features. The BD-BACTEC system offers several important features, which is rapid detection of microbial growth, continuous automated monitoring, wide range of bottle types, including aerobic and aerobic predatory and mycobacterial bottles. Next, let's move to the workflow and process. The first one is blood collection. The process begins with blood collection from the patient. A blood sample is collected from the patient and inoculated into specialized bottles containing a nutrient broth. Number 2, bottle labeling and barcoded. Bottles are labeled and barcoded for identification. Each bottle contains a grow medium and a built-in sensor that will allow the detection of microbial growth. Number 3, incubation. The bottles are placed in an automated machine and incubated bottles at 35 to 37 while the system continuously monitors for signs of microbial growth. Number 4, positive detection. When the system detects growth, it signals a positive culture, and laboratory personnel can then perform further tests. A positive signal is triggered when carbon dioxide exceeds threshold that show growth detected. And lastly, for further analysis, a sample from the positive bottle is used to prepare for a grain stain, subculture onto solid media for further identification. And lastly, antimicrobial susceptibility testing.
Let's talk about the biomarkers used in the laboratory diagnosis of bloodstream infections and sepsis. Biomarkers help in rapid detection, risk stratification, prognosis, and monitoring treatment response. Firstly, C-reactive protein (CRP). CRP is an acute phase reactant that is synthesized in the liver in response to IL-6. It is sensitive but not specific for bacterial infections. CRP can also help guide the duration of antibiotic therapy. However, its limitation is that it can also be elevated in non-infectious inflammation, such as trauma, surgery, or autoimmune diseases. Next, procalcitonin, PCT. PCT is a popular biomarker for bacterial infections and sepsis. It is the prohormone of calcitonin, and in healthy individual, the level is low. During bacterial infection, PCT becomes rapidly induced in almost every organ and released into circulation. It is considered the most ideal biomarker to distinguish bacterial infection from non-infectious causes of inflammation and is widely used in sepsis management. Lastly, we also have some newer biomarkers being explored, like the IL-6, IL-10 ratio, presepsin for early sepsis, and interleukins such as IL-6, IL-8, IL-10, and TNF-alpha. They can show inflammation early, but they're still not commonly available in routine labs.
rapid molecular identification is a high specific and sensitive diagnostic technique that targeting DNA or RNA of pathogens. It faster and accurate identification enables early detection of multiple pathogens causing infection, as well as support clinical decision to narrow the antibiotic therapy for efficient treatments. Generally, before detection is done, pure DNA or RNA are obtained by extraction process, then it is amplified to increase test sensitivity. The first current trend is multiplex real-time PCR, which allows for simultaneous multi-target amplification and detection of gene sequences in a single reaction of thermal cycling process. Amplification is done by the primers, while detection of DNA shown by the intensity of fluorescence signal produced by fluorophore-based probes. Increasing DNA amplification will increase fluorescent signal emitted, indicating the presence of the target DNA. The advantage is that it allows for rapid detection of many sepsis-causing organisms in one run, with both qualitative and quantitative measurements. Next is multiplex lamp that do also amplify and detects multiple pathogens DNA but at constant temperature. Specialized multi-primer system with the help of PSC DNA polymerase that capable for strand displacement activity enable for amplification of multiple target DNAs continuously and faster. Loop structures produced by loop primers enhance amplification products. Detection methods include turbidity observation, uses of fluorescent dyes, and colorimetric measurement. The higher specificity and sensitivity of the multiplex lamp has shortened the turnaround time and thus suitable for point-of-care testing as it performs at constant temperature.
To conclude, bloodstream infection and sepsis are extremely dangerous conditions which require fast and accurate diagnosis and treatment. Blood culture is important for identifying the exact pathogen. Biomarker indicate the presence and severity of infection, while rapid molecular identification provide quick identification of pathogen. Using this method improve early diagnosis and treatment and help save more lives.